Well, welcome everyone. And they always keep the best for last, so we're second to last session for the summit for the day. So many of you will travel tonight and tomorrow, so safe travels, and hope you enjoyed the summit. We're going to be talking today about the data lake on AWS. But I also wanted to point out that throughout the last 2 days, there's been a lot of session on Delta. So I hope you had a chance to actually attend some of these sessions. There was about 10 sessions overall. And hopefully you had a chance to see the keynote yesterday from Michael Emberst. And if you haven't, please go back to the Databricks website. The video's on there. There was a lot of announcement around Delta and a numbers of other product announcements. So it'd be worth it to go look at that. So we'll do a few introductions like we were introduced. I'm a AWS Partner Solution Architect. I specifically focus on AWS, and I work with the AWS ecosystem and partners. Jordan?
Hi, my name is Jordan Martz. Hey, nice to meet you guys. So I'm based in North America, so what I cover are consulting partners for Databricks that are implementing Amazon across a plethora of different accounts and verticals. So I also want to say thank you. I've got my teammate Ryan over here. He's also on our team, specializing in AWS, and big thanks to him for all the work that we've done. But thank you for joining us as well.
Yep. All right, so what we'll cover today, we definitely going to demonstrate how we're going to leverage the AWS View Catalog from the Databricks notebooks, making sure that all your metadata is properly cataloged. We're also going to demonstrate using the crawler, so using the actual AWS Glue capability to actually demonstrate that not only you can do this directly from the Databricks notebooks, but as well that you can also use the crawler to do that as well, just to kind of show you the two different angles. Then we'll use Delta to actually go in and read this data, cleanse the data, and also at that point publish that data so that we can consume it from Athena, and demonstrate a nice little dashboard with QuickSight, and we hope to leave you with some good recommendations towards the end of the session.
So the dream that we have was the idea that we're going to be able to take and hook from two streaming sources, right? So in our environment today, I'm going to be taking like clickstream analytics and different applications from your CRM and merging them together off these Kinesis tools. And when you're bringing those together, you want to stream them into S3 and also into Delta, right? So the data lake architecture that we want to build together and that we're building, and you can see the Delta symbol right now, is really focused on 3 key points. What you're looking at is when you unify like batching and streaming, I mean, really, it's never been done without, like Spark does that unification in such an elegant, nice manner that in my exposure to hundreds of different systems, it's been really hard to do this in a nice orchestration or continuously manage it. So what happens is as you want to be able to replay this, like in the past I worked with a CDC vendor, two of the largest ones in that market. So I've come from that space of like, why are we going to have that auditability and that replay reel of what happened at yesterday at 2 p.m. and broke the underlying stream, and why do we need to change that? So when you look at these different historical events that would come from one of these streams and you do that replay, Delta's got that capability. The further part is I used to have to try and handle in the open source realm Kafka, but trying to be able to scale that consumption had some opportunities that are really alleviated by the elastic scaling that comes with Databricks platforms and tools. So when you look at it for like, I need to scale this number of nodes per stream, huge capability. Load balancing capability with the elastic scaling gives my customers, like I've got one right now, a medical device company, and I can see how they're scaling out. I think they take, just for a minute's consumption, because like an hourly consumption, they're taking like 1,000 nodes that they need to elastically scale up. I remember just the orchestration of getting that ability to get the resources and bring that together took forever. And so the ability to do that naturally with our tools, that changed the overall formula for me and my experience working with those types of customers. As I dealt with this as well, we go into like bring these different types of platforms together. So like in the open source realm, when I worked with Kafka, or Kinesis, both of them have different functionality points, right? You know, Kafka, when you take it, you have to manage some of the infrastructure, decide what's inside of it, but you have a lot of flexibility to manage like how data skews as it comes in and how you want to handle it. And if you look at in the middle point, the different types of data sources that you have, you've got sources like the customer data or the web data. As you bring in those different types of data that I'll be showing you today, they each have different characteristics and why you want to choose different components. And so these three sources for ingestion that we would pull in using Spark, as you continuously and incrementally do this, you want to make sure that you choose an incrementation that's efficient and effective before as you want to render this either for reporting or applications that you're going to be using and services that you build. So we arrive at the Delta Lake. I think you guys have heard the term Delta in the past, over the past couple days. So we derive the Delta Lake as the dream of what we're trying to build in our definition of a Delta architecture. That Delta architecture includes those 3 points that I just made, and as well, they continue on that path. So what I want to do is give you 5 key things to think about. When you think about these 3 things, what I want you to do is these are the key factors that you need to consider when you're understanding what a Delta Lake defines. When I take in and want to understand how I'm consuming in real time and consistency, what does that mean for you? Like at a point in time, how much am I going to roll this back? What's my back propagation? Those type of problems, I want that consistent capability. I'm going to show you a unique identifier that then is going to need a duplicate detection, resolving that naturally coming off of a Kafka queue. Really nice to be able to do. There's also the incrementation of those files as they're being pulled in to that folder share. And as you're bringing that in, you can then have that metadata scalable and handled, et cetera. Even then incorporating into Delta, as I load in all this data, I may need to roll back to yesterday's data to understand what the difference report of that data would be. So I can include that inside my Delta files. I can then also stream that data off the same pipeline, understanding that difference report, and then, you know, naturally not all the data is going to come in as real time as you want it to be. So you want to handle for those real time use cases. And that's described as a late arriving data set, so you can display that data as it's going. What I'm going to do is I'm going to hand this over to Denis to then give an overview of some of the different components in the Amazon ecosystem and how that affects us.
So for those of you that are familiar with AWS, so in today's talk, we're going to cover Glue very extensively. And I mean, Glue is at the center of the solution. Glue has a few features that we're going to leverage part of the exercise today. We'll look at the console. We'll also demonstrate how we're going to integrate our data sets and our metadata into the catalog. Obviously, we'll also demonstrate the crawler. Glue also support ETL operations, but those ETL operations today are going to be done within the Databricks notebooks environment. And you know, the Glue also support job systems, and also Databricks as a job system as well. So why Glue? I mean, Glue is an enterprise metastore within the AWS environment. So if you were today going to use notebooks, you have a dedicated Hive metastore within each of your workspace. Now, if you want to decentralize and you want to have or leverage an enterprise metastore, either you have to do your own, or you can leverage Glue to do that. So it's also an ability for us to easily integrate a single catalog across multiple different workspaces or multiple accounts within your AWS ecosystem. And for us, it's also providing us the ability to do identity and access management with credential pass-through using Glue. We're also going to talk about Athena. Athena is really a serverless environment. It's fully integrated with, again, the ecosystem. It's a paper query. You can also easily use a standard SQL interface to do that. So it's really second nature for a data analyst to use. So from the ETL and the refinement or the manipulation of the data, which is then published on your S3 environment, you can also now easily, without having a cluster running, leveraging Athena to go and query your data that sits on S3. And then we'll finalize this with a series of, we have one dashboard where we can actually demonstrate the fact that from the streaming data that came in and that's been manipulated and updated and then published to Athena, then we'll use QuickSight to actually leverage that data and query that data to a visualization tool. Now, obviously, AWS provided numbers of third-party services. This talk is specifically focusing on first-party services. You could easily replace QuickSight by a Tableau or Looker or any of those components as well within the ecosystem. So let's talk about the architecture. So obviously, with Delta, we have the ability to stream data and as well ingest batch data at the same time, because we can support multiple readers, multiple writers. Obviously, Delta provides that reliability. So if you follow a medallion process, that data comes in either via a streaming component. Leveraging Delta, you can now follow this cleansing process that you're all very familiar with from a warehousing standpoint, and Delta provides you that ability to do this. You can also basically use your data that's on S3, crawl that data if you wish to do it that way, and then update your metadata through the catalog. So for the exercise today, once the data is going to reach the catalog, we'll externalize that data over to Athena and then further to QuickSight. You can also take the data now that's been manipulated and cleansed and then push it to Redshift. So you have that full life cycle with all the major services that are running within your AWS environment. Now on top, obviously, we're going to leverage IAM management. All of our clusters are running with security. Security has been very limited to the permissions that are necessary. And as of our latest announcement of DBR 5.5, we also support credential pass-through, which is fine-grained access control. So today's session will go through a demo use case. So Jordan here is going to show us really shortly here a series of demos. So we're going to have 2 streams coming in. They're going to land on Delta. And then from there, we're going to take that data, we're going to join it together, we're going to manipulate it, and you'll see some ACID transaction capability, some DML support capability as well that we have within Delta that you've heard through the week. All of this will get cataloged and accessed through Glue. And again, that crawler is going to come in as well and start complementing the enterprise catalog. Once we've read from the crawler, we'll take that file, and then we'll now inject that file into the file that was joined previously. And then that file will then get exposed to Athena, and it will also then query this through QuickSight. So that's kind of the end-to-end scenario that today we're going to demonstrate via Sears Notebook. Now, that medallion process where you have your gold data set could also be pushed out at this point into Redshift, and then Redshift could also be queried by QuickSight. So that's an end-to-end scenario that alleviates the complexity, leveraging all the different connectors. And as we're going through this, we at Databricks have developed a series of proprietary connectors to speed up and to ensure the reliability of that data flow throughout the use case.
That makes sense too, because Dennis, when you're looking at it from the perspective of building out a data lake, and you're looking at the different streams that are over here, what you're looking at is that overall history all living in the data lake. So if you need to like populate a Redshift by region or by one of those different use cases, or you have an enterprise reporting tool down at the like a store or localized level, you can combine Redshift and Athena very naturally. So let me get into that. Does that work?
Yep.
All right. So I'm going to get into my notebook. What I have right here is that initial like architecture slide that we had around usable data lakes. And in my use case, I've only got like 4 of these different notebooks. What I've done is I've cleaned up like a bunch of loads that I've done in the past just to make sure that my demo ran. But what I'm going to show you shortly are like 2 streams that were being produced to read into here. What I'm going to do is mount a storage point called e-commerce, and we're going to bring that e-commerce in and collect this database. We call it e-commerce. At the end of the day, this e-commerce is going to contain all of this data. Data that's going to be ready for Athena, data that's going to be clicks, and data that's going to be profile. Also, I'm going to give you a little bit of an aggregation point to show you some reporting. But what I'm doing right now is I'm running 2 actor data sets coming off of Kinesis right here. I haven't really applied any schema information here, but previously, like I worked at I say I worked at a pizza store, so like I used to like hawk data. So like the way that you would click on websites and understand how you're going to buy, like whether you're going to upsell and add some appetizers or different components to that one. It's the actual bid is the fundamental like price or the core aggregation point that we're looking at coming out of here, and we've decided to pull from this region over in US West 2. So I've got 2 data sets. Right now I'm pulling in the clicks data right here. Now I'm going to pull in this profile data up here. And this is actually CDC data. Like for instance, you could be taking this out of operational reporting systems and you could be having live data sets that are pulling in. As I'm doing that, neither one of them I'm applying the schema. You'll see how I apply it later. So right here. As I apply these later, I'm going to be able to consume though 2 of these different data sets and be absorbing both of those. These are just JSON records of these click streams, and you can see some of that output. What I'm going to do is show you in real time where that's coming in. So this producer's notebook, I've got 2 active streams that I've scheduled so that they're both being able to pull in both this click producer and profile producer, and all that is definition of 2 notebooks that I pull in. And what I've done is I've hooked in different detail around Kinesis. So using this database that's going to load into S3, I'm getting the right proper timestamps and other definitions that you would need to consume. But as I go down here, I'm trying to pull in 10 records and rows per second and giving it this click information. I've got exchange information, where the publisher came from, how it clicked, and actually the bid detail of how it came in. So here's some code right here that this is how you connect to a Kinesis endpoint. What I'm doing right now is I'm going to print out what words and what records are going to come from there. And as I do that, I'm going to be collecting records that are going to show me where that record is located. So as I pull that in, I've got the time in milliseconds, the record, and the instance, and I pull in the number of records. So this has already been run, so it's kind of populated the whole data set, and that's where you can see it in the read streams. I'll hop into the clicks in a minute. So as I've gone into this data set, and I've brought in a bunch of this data over the past period of time. So as you can see, the past 10 minutes, we're probably bringing in what, like, how many rows are we bringing in? I think it was like 1,000 over the last couple of minutes. And as we bring all that data in, you can expose it right here. And here's this CDC flow. Here's another set of that same records running from an ephemeral notebook. Sorry, that went too fast with that one. There we go. Clicking. Your mouse pad clicks fast. All right, there we go. So what I'm going to do right now is I've got click data and I got profile data, and what I've taken in here is we're going to render and we're going to apply to both of those JSON the schemas that we defined above. As we're starting to do this, we start rendering 2 data sets, as you can see right here. And as we're running each one of those, we're going to start to then join and create a data set that we call the user profile data. It's emerging. And we're loading it to Delta right here. So as you create these data frames, you start something empty and you continue to overwrite it by creating this table called profile data, and we're going to render all that data. What's next is quite interesting for rendering micro-batch tables and merging them together. What we've done is we've run this batch window, and what we're taking in are these streaming updates as the output, and we're then going to make sure that duplicate IDs are resolved as we're doing our micro-batched merge. The merge functionality in Delta then can take in those merged entities, and it can resolve them as it's coming in. So this is just a function call, because I'm going to call that for each batch right here and run these operations. So as you can see, it's been running for the past couple of minutes, and it's checkpointing all that data to a local location called profile CDC right here. It's also then dropping them in. We've set this as the data root, which is just the bucket definition that we're taking in.
So that bucket definition was defined up front in the first cell, Jordan, right?
Sorry, I can't hear you.
I think the data root bucket format, all the parameters were defined in the first cell.
That's right, sorry. And when you take it into here, you're showing some of the different data sets that we've processed. So we've got click, profile data, and we've displayed this information as we're going. Right here is an exposure of what data comes in here. So if I click in here, I can then show you that it's in like the unique identifier, the zip, and all that information as we're going. What we're going to do right now is we're going to join these clicks and profiles together and combine those into a Delta table called click with profile. This output of those data sets are right here based upon joining clicks to profiles on the unique ID that we resolved. And what we're doing is we're writing that stream out to a series of delta tables or a delta file that's consuming this click with profile information and merging that schema as we're joining those two tables together. As we join that, we're then going to load this. Sorry, I didn't want you guys to wait for us to be running all this code while we're, you have to wait 20 seconds. You're like the pause of moment in the day. And as you do this, you create this table, click with profile, and we display what we've joined together. So we've got the actual click information up to the bid, as well as then the profile CDC that's being loaded. As we take that in, we're loading all of this data, and we're making sure that we have a consistent profile of those records. And so here's a unique profile of each instance of a click on the website, bringing in and merged to some instance that's a net new record of a profile at that location. So it's like I clicked on the website, and I'm one of those individuals that's been brought together. As I take this in, we're going to be showing different locales right here. So from New York to San Fran across to Atlanta, I'm taking the geolocation and actually understanding how much they bid on the website by the click, and then order it by this using Spark SQL. As you can be able to expose this, we're going to take the aggregate store, and we're reading in and loading this data, and we're then applying specific calculations to this. So as we look at this, we're going to be showing what we call the signal store. The signal store is accounting for geolocations that are not in the same locale. And what I want to do is prepare that for a reporting use case in Athena. So as we prepare that, we're going to have two output data sets. We're going to take this click with profile stream to give you a little more understanding of what's inside the data, and then we're going to use this aggregation point to do alerts using the signal store. So as we take that profile data in and we run the different signal store data, we've exposed that using Glue, and we're able to expose this signal store to that data and see where they're not actually, so like this is a unique location, but we haven't defined that unique location yet. So there's like, if it's a 1, that means it's actually a net new location that we clicked on the website. So as you bring this data together, we're clicking with the profile and running this. Here I'm going to remove this standpoint and rerun this. I can check the publication, the locale, the zip. Gives us a little more enriched locale. So these are all net new geos by cities that have found duplicate locations that they're finding by where they clicked on it. So what I've done is I'm writing out to this signal store and preparing this for Athena. So as we're running this, we need to be able to have the output node for these locales, and we're going to take in and create the signal store using this delta location, and we output it. This signal store is then picked up, and it shows like net new locales. So now that we've prepared this for Athena, Dennis, I think it's time to pass it to you to create this Athena table, and we're going to be adding it and then dropping it and creating that for you to profile right here.
Yep, thanks. All right, so Jordan is the engineer on the team. He's actually set up all these streams, so I'm going to take the data analyst persona. I've got a data set, and now I've been tasked to actually publish this data on a dashboard. So I'm going to go look at this data and see what it's made of. All right, so I'm actually, this is actually already created. So now, from the Databricks tab itself, from the data tab, you can actually see the actual Glue catalog. So the tables that are in here are also the tables that are also available in the Glue catalog. So let me just show you the Glue catalog as well. So as I bring up the Glue UI, so right now I'm looking at this e-commerce database. So all of the tables that are in my Glue, the metadata that's in the Glue catalog is also available on my data tab within the notebook itself. So as I said earlier, if you don't configure Glue, you could have an individual metastore associated to your workspace. Now this particular workspace is actually using the enterprise Glue metastore. So now I could use this metastore across multiple workspaces and multiple different accounts within AWS. All right, so I've got this. It's been defined. I've got my external table, and now I'm actually going to go and just look at this data to make sure that this is actually what I really want to work with. because I've been told that I'm not allowed to use PII data on my dashboard. So I will actually go and look at the Athena. So Athena's going to come up. So I'll use the Athena query editor, and I will actually look at my profile data that's right here. So I'm going to use this guy. I'm going to go see preview. So the query's running. It should take a few minutes, maybe a few hours. Anybody has a good joke? No. It's going to come back pretty soon. So it's a matter of seconds. If the demo gods are with us, it's going to be faster.
I'm going to get you a Jeopardy button for like the moment.
Yeah. All right. Well, seems that it's, let me see here. Let me rerun this. So I'm going to recreate the external table. For some reason it was not rendering. All right. So it is still running. Well, the entire demo is based on this table, so it better render. All right. Well, let's go over here. Let's go to the next notebook. All right. So what I'm going to do here is I know the data, so I'm actually going to go and query the database. So yes, I do have my database, e-commerce, and I'm actually going to do from here. I'm actually going to go, and I'm a SQL guy, so I don't want to do any Python here at this point. So I'm just going to show. I'm going to go show tables. There we go. So I'm in the right place. So I'm going to use this e-commerce database. I'm going to clean it up a bit. So when the profile data was created, there was a lot of personal information that was attached to from the merge. And I want to remove that entirely so I don't publish that content. There was also a bunch of state codes that were not populated as well. So what I'm actually going to do is I actually going to go to Glue, and I'm going to use a crawler, and I'm going to crawl the data sets that I've uploaded on my S3 bucket, which contains my state, my lat and long information, and I'm just going to do this. So I'm going to go over to my crawlers. So I've got this crawler right here that I just ran earlier today. So that actually read the file from S3, populated the table definition and the metadata in the catalog, and actually just store everything into Glue. So from here, this is the table that was created earlier on. So it actually points to that S3 location. Okay. And that's the definition that was basically extracted for the metadata. All right, so now I have some data that resides in Delta. I now have a new table that's been exposed to Athena, and I've actually queried an S3 bucket, and I populated that state data into my catalog. I'm going to go back to Athena here, and hopefully it's going to respond here. There we go. All right. The demo gods. Ryan, did you call them? No? All right. So as I was saying, there's a numbers of fields that are null, and there's also PII data for some of these transactions. I don't want to have that, so what I'm going to go now is I'm going to go cleanse that data. I'm going to remove the PII data. I'm going to take the data that I just crawl from Glue, and I'm going to go update the state for those records, and I'm going to add a lat and long to it. So So basically, I'm going to merge some data using delta, all right? So let me go back to so this is the actual state data set that I've uploaded, that crawl. So this is the data. So let's see here, Atlanta. I get a couple of cities here. So Chicago, I've got about 11 records. So I've got about 11 states. All right, so now I basically have this data so that Jordan produced, because I kind of consider that data to be a silver level within my medallion process. So I'm going to take that. I'm actually going to produce a gold data set or feature table that I'm going to use for QuickSight. So I'm creating this new table. I've actually, from this table definition, I've dropped all the columns, all the attributes that I don't want, and I'm adding a Latin long, and I've renamed that state column to state code. I'm a little touchy on naming convention. I'm a data analyst, so I really want to stay within the enterprise definitions, so I'm using this. So just to show here, again, I'm a data analyst. I want to make sure that my column attributes are defined properly here. And I want to make sure that, okay, this looks good, state code, Latin long. So now I'm going to take this data from the click with profile that's produced from the streams, and I'm going to now populate this data within this gold table, and I'm actually nullifying the state, the lat, and the long, right? And I've removed this entire set of PII data that was previously introduced. So let's do this. So all along, these are all delta table, by the way, and they're all being defined and stored in Glue as well, in my centralized Glue store. All right, so let's look at this data now. So as I said, my state code is null, my Latin long is null. So now I'm going to use delta to take this new file, that's this gold medallion table that I want to expose to my dashboard. I'm taking this file, and I'm going to merge this file with the proper state and then Latin long. And I'm going to join this on the city. So this merge statement, if you were to do this with Parquet file, it's about like a 7 to 8 step process. As you're manipulating, because everything is immutable, with delta, you can actually just directly, and using a very single statement, so reducing your pipeline complexity, using delta, you just merge those two data sets. Or if some of you have done correlated update statements, it's not that simple in SQL, right? All right, so this is up there. Let me go look at my data set. I now should have my city. I do have my city. I do have my Latin long. I'm good. And now I'm going to publish this to Athena. And this generate statement is how we produce that external symbolic link. Again, this is all pointing back to your S3 bucket. All of this is all within your S3 and all your VPC and all of your personal accounts. So all of this data that we're interacting with is all under your control. All right, so I'm going to publish this to Athena. All right, so now I'm going to go back to Athena, and I should have a couple of more tables. All right, so now I have my gold table over here. Let's go and preview that gold table, so it's running. All right. Oh, I used the wrong one. No, should be fine. Okay, so I do have some that are empty. All right. So now let me switch over. So we took data from the stream. We manipulated that data. We also then used delta to eliminate additional columns, and then we actually then used the merge statement to actually, again, reassemble the tables that we were interested in. And now that data is available externally from Athena, and then we're going to do QuickSight is now connecting through Athena to query this data. So I'm a data analyst. Now I'm going to validate those values, and I feel comfortable that, well, I have my records per publisher, so I'm going to do a bunch of queries, validate this. But I have an end-to-end scenario where I was able to stream data, manipulate data, and then report on it, all from a single environment, leveraging all the first-party servers within AWS. Right. Now, obviously, this reporting can also be accomplished by a third-party tool, but the intent here is to demonstrate the integration with the services. Now, one additional point here that I want to make sure that everybody's aware of is this red box as well defines that all these clusters that we're running, that we're using to actually manipulate this content, those EC2 instances that were spinning up when we're launching the clusters, this is basically, think of it as basically your AWS account. So these EC2 instances, you can track how many instances that we're running and the cluster size and how many nodes that we're actually consuming to produce all this end-to-end scenario. Now, the concept of VPC here will also be introduced at the different layers. It is good practice to introduce different VPCs for Redshift, for instance, versus your cluster. This is not representative within this diagram, but this is kind of just give you the holistic holy grail to understand the flow and the connection. All right, so we got about 3 minutes. So we're going to wrap this up here.
Yeah, so Dennis, I think a lot of the time to agree with your statement was all about like those peering use cases, agreed. And since you want to be able to have, like your pipelines, for instance, have specific SLAs, a lot of the time when you scale out some of our infrastructure, you're never going to usually have 2 sources, you're going to have many, many, many more. So to eliminate the burden of scaling some of those types of consumptions from all these different sources, Databricks is going to give you a lot of that functionality, especially because we're following a Lambda architecture, right? Some of these batch operations could go directly to Delta and bypass some of those streaming requirements and message requirements. But also, we looked at use cases such as integrations with CDC, some of the different requirements you have around GDPR, right? Some of that cleansing. You could even use other tools out there with data protection to be able to handle for that. Also, just rules around sessionization, like how am I going to handle different production of data, and how am I going to look at whether I need to roll it back or where that is going to be processed and how. They're also deduping the data, right? Making sure that you've got a proper cleansing process with that merge. Overall, I mean, this is the paradigm shift that you're seeing with cloud tools and how Databricks can help you. When you're looking at it, the infrastructure cost, the elasticity, and the independent compute of each step, each one of those reduces the overall infrastructure, and this is a reason why a lot of you are here today. So overall, we're looking at the considerations of why you use Delta and why you can handle the different sources. So we just wanted to make sure we marked the different multiplex versus singleplex versus multiplex when you're taking in each event and consuming them with different types of schemas and handling for those schemas, as well as inferring. Let's say I have a net new schema I need to evolve based upon different input parameters that come in on the data set. You have a lot of this flexibility all within Delta. I've seen hundreds of these in the IoT use case where like you needed to interchange the schema at different intervals, and that's where you have a lot of that functionality around streaming use cases. Dennis, I'm going to turn it over to you as well.
All right, I'd just like to leave everybody here with a few kind of consideration and summary of the session. As we've done all this work, obviously, when we're setting up clusters on AWS, or actually for any environment for that matter, always provide the less restrictive access possible that's required to what you need to accomplish. So this is a good practice to do. Also, when you define your IAM roles and your policies as well, always leverage identity-based policies and resource-based policies and build that whatever is required for the actual role that you're trying to accomplish. If I have a data scientist or I have a data engineer or a data analyst, make sure that whatever policy you're building is actually just required is only, that you include into your policy the minimum that's required as well, and build it from that perspective. Always also, when you start thinking about building using all these party service, think about permission at the table level. I know that we're dealing with S3 and a set of buckets and files, but now that you're introducing all these data sets or these files into Glue, start thinking about the concept of table. And I'll apply your permission at the table level as well. And I would say that finally, one of the final point that we want to do is, once you start using streaming, you're gonna, just don't go back to batch, because everything now is actually streaming, and everything is so simple to do. It doesn't have to be running continuously every minute. You can have streaming jobs that are running, once a day essentially, but use the concept, apply the principle of streaming to everything you do in your data lake. So on that note,
Thank you.
I think this is the information that we had to cover for you guys today.
That's all, folks. Thank you.
Any questions?
Any questions? Anybody has?
Can't find Vikas from the.
Hello. Yeah, sorry. You're talking about exposing your data with Athena. Do you ever run into certain performance issues when using Athena, and how do you resolve them?
So in this particular case, if you think about the data analyst persona, I was using Athena to really curate the data, and I know that I have an ultimate task to produce a dashboard. So it's just an easy method for us to look and leveraging Athena within the ecosystem. It's not necessarily like a characteristic in terms of, there's cost consideration using Athena versus if you'd use another BI tool. Or you could actually use Databricks and leave the data within and just use the notebooks and use the SQL within Databricks itself. So this was just to demonstrate the integration point that we have within the environment. So it's not necessarily a recommendation at this point, but more so to demonstrate how we integrate with the endpoint.
Okay, so it's correct to assume that it's more like an exploratory tool, or?
Yeah, from a data analysis perspective, obviously, yes. Some companies are actually leveraging this for some of their SQL and some of their BI capabilities, within the AWS ecosystem itself. But it'll vary. Your mileage is going to vary based on what you're trying to accomplish and how many users you're going to have, and then the concurrency that you're looking for.
Okay, last question. Then if you're exposing production data, for example, Tableau, in which format or with which tool do you publish it? Is it like a typical Elasticsearch database, or?
So all this data today was produced using the Delta Lake. So, Tableau has a connector. We've recently released a connector with Tableau that actually can query Delta tables. Tableau is the only BI tool in the marketplace that does that. If you want to do this with Athena, that's the other solution that you have, but you have to create that external definition, so it's a manifest file that really Athena is reading.
All right, I guess we are running out of time. So yeah, anyone? Last question? Yeah, one over there.
I had a couple questions, so whatever we have time for, essentially. So one of the questions is, given that AWS is also providing lake formation as a service for building data lakes, how do you see that evolving? Will AWS standardize on using Delta as a mechanism of doing these upserts, or would you kind of build that functionality natively somehow in AWS? That's question one. My other question was around, we have this multi-staged architecture in the form of the bronze layer, the silver, and the gold. Doesn't that kind of duplicate the same data? So for example, in your demo, you had the example of removing the PII data between your raw data. And so typically, because I come from banking, that would be a very typical thing, but that would be more from an exploratory standpoint. Essentially, you want to suppress the PII data from the analysts. Is there a better way of doing it, or is that kind of the proposed architecture, but that would really involve duplicating that entire data set multiple times for the simple purpose of really masking that information? And
So let me handle the lake formation question right away.
okay.
So we are actively working with AWS on how to actually leverage and being part of the lake formation strategy. Today, lake formation is really a preliminary product. A lot of the APIs are not available to the partners. Now, AWS acknowledges this, so the product has made the market, but it's still, there's a lot of evolution that's required. So our intention is actually being part of that lake formation down the road. So I mean, obviously, we don't have a crystal ball, but at this point, we're actively working with AWS, and hopefully, in the months to come or the quarters to come, we'll have an opportunity to be at the table and leveraging Databricks within, give the customer the opportunity to either pick, which platform they want to use to integrate with lake formation. So that's the goal. You were asking about the medallion process, the bronze, silver to gold process. So if you think about this, I mean, this is a really traditional data warehouse processing model. And what we're saying is, if you introduce this in Delta because of the capability that we have in Delta, now you can eliminate some of the concurrency challenge. So if you were to use Redshift as your data warehousing for visualization and true data warehousing workload, so now you can alleviate the choking points that you might encounter using Redshift, and then you can now push that scalability back to Databricks. And using Delta, we have all this warehousing construct, like the merge and ACID transaction and full DML support. So you can now move that medallion process a little earlier on the platform and really push only the curated data back to Redshift or back to the visualization level. So really truly leveraging those services to what they're really meant for.
I can let me pile onto that one. So when you take in some of the data, you're going to go through like an imputation process and a deduping and a merging. You don't have to carry the redundancy of that data. You're just going through the natural stages, and that's why we mark it more of a pattern to follow.
Okay, thanks. Just two last questions. So the UDFs so suppose, I'm trying to understand from a data scientist persona, if they are building, UDFs, where they have built the models, can that be integrated with Athena or with QuickSight?
Well, since you're going to have outputs of the UDFs.
Yeah, so basically if you expose a UDF as a function, as a SQL function,
sure.
Can you integrate that through Athena?
I don't think you could do that today because you're looking for Spark operations to be able to call that, and it's a different process that's outside of there. And usually why the goal of the BI workload that we were exposing was that we wanted to get our data curated for that. So I've seen multiple outputs that are addressed from curated data sets that have already had the outputs, but you're looking for a dynamic entity. One of the other use cases is why we have BI vendors working with us is to be able to have the ability to call Spark for that level of dynamicism that Athena may not may not be a use case for. Yeah.
All right, thanks. Just very quickly, can we get access to this demo?
Sure, absolutely.
How do I get the link?
So we're going to post the slides, and we can then post the DBC so you can read the output.
Have the DBC. Okay, great. Thank you so much.